Good afternoon. We will discuss our topic today, that is octane number, cetane numbers, and then the alternative fuels which are used for the internal combustion engine operation. But before we go to discuss about the alternative fuels, I would like to discuss about the different types of conventional fuels which are used for the IC engine operation. Then we will briefly discuss about the alternative fuels like the use of methanol, ethanol, and also the problems associated with their use. And finally, we will be discussing about the internal engine combustion. Then we will see that these two important numbers, that is octane number and cetane number, are very important to know. So, to start with, today we will see that what are the different types of fuels used for the operation of internal combustion engines. So, basically the types of fuels which are used for the internal combustion engine can be broadly categorized into three different classes, that is solid fuel, then liquid fuel, and also the gaseous fuel. Now, we will discuss that what are the different advantages or disadvantages are there with the use of these three different kinds of fuel. Now, when we discuss about, rather when we talk about solid fuel if we use for the internal combustion engine operation, we have seen that at least we did not discuss till now the SI engine injection system, but we have discussed about the SI engine injection system, and we have seen that fuel injection is very important. That means we need to inject fuel, and that is why nowadays carburation is almost obsolete. So, when we talk about fuel injection system, we need to know three different important parameters, that is the cone angle, penetration depth, and the average size of the distribution. Now, question is, when we talk about fuel distribution, fuel injection, then it is very difficult to inject fuel if the fuel is solid. That means solid fuel, when we talk about, one important disadvantage is that injection problem. Not only that, we will have another problem, that is after combustion the residue. So, the residue or the ash. So, distribution of fuel, that is associated with the injection system, and secondly the disposal of the solid residue or ash that is there. So, these two different problems are very important when we talk about solid as a fuel. So, solid fuel, we have seen that one problem is the distribution as well as fuel injection. Number two, removal of solid residue or ash. So, these two are the different problems which are associated with the solid fuels. So, now we will discuss about the gaseous fuel. Then we will see that if we try to compare the merits or demerits, then we will see that the liquid fuels are having a few advantageous features. So, now if we try to discuss about the important, I can say aspects of the gaseous fuel, rather the use of gaseous fuel, then gaseous fuel is having a few disadvantages, and also it is having another one important advantage, that is the fuel is gaseous. So, unlike liquid fuels, the gaseous fuels are having less inertia. So, the distribution will be very much, I can say easy, but at the same time we do not require any pumping system to pump the gaseous fuel from one place to other. Instead, the fuel, because of the low inertia effect, it can move from one place to other place. Of course, we need to have slight pressure difference, but this distribution so if I write the advantage of gaseous fuel, then the distribution is relatively easy. I can write distribution is relatively easier as compared to that of the liquid fuel. Of course, solid fuel I am not considering, solid fuel distribution problem is really difficult. So, liquid fuel, but although this is one advantage, although the gaseous fuel is having this kind of advantageous feature, but at the same time we are having a few disadvantages. What are those? So, now if I try to write the disadvantages of the gaseous fuel, important disadvantage is that the storage. So, we need to handle large amount of gaseous fuel. So, storage will be one big problem. So, one problem is storage. Some gaseous fuel can be liquefied under pressure, but again this is very costly. So, the storage is very important problem for the gaseous fuel, and also this becomes even more important with the moving so that is large storage tank, so I can say movement of large storage tank. So, it will occupy huge space. Not only that, the transportation of that huge tank will have another problem. So, now if we closely look at these points, that is solid fuel distribution is really problem. Not only that, removal of the solid residue or ash. On the other hand, if we talk about gaseous fuel, it is having of course an advantage, that is distribution is relatively easy as compared to the liquid fuels, but at the same time if we use gaseous fuel, then we are inviting another problem like the storage tank will be an important issue. Not only that, we require a large storage tank to store the fuel, and while we are considering large fuel tank, then of course the movement of the or transportation of that large tank will be another issue. So, considering these issues, liquid fuel is largely used or mostly used for the internal combustion engine operation. So, these fuels are mostly used for IC engine operation. Right. Now, at least we should know that liquid fuels will have definitely a few advantages, which are if we compare them with the other different fuels, of course those aspects will be advantageous, and we cannot say that liquid fuel will have always advantageous features. Again we will have kind of disadvantages. That is very important. Even if we can see from this that because of this inertia we need to have kind of pump. That is what we have seen, that if we need to inject fuel through fuel injector, then we need one nozzle and there will be huge pressure drop across the nozzle. So, we need to connect one fuel pump with the circuit, and that fuel pump will be responsible to build up that pressure. So, this is another important problem associated with the distribution of the liquid fuel. But even then these liquid fuels are mostly used for the internal combustion engine operation. So, I can say now the liquid fuels are basically hydrocarbon, rather family of hydrocarbon. So, we should know at least by how we can extract liquid fuel from crude oil and what are the different processes associated with that extraction. So, and that I will discuss with the block diagram. So, that means liquid fuel extraction. So, if I write the block diagram, that is crude petroleum, crude petroleum, this is coming from oil wells. I will write in details, but for the time being at least I should label those, that this crude petroleum which is classified based on the residue left after distillation. Then this crude petroleum is taken to the oil refinery, and this oil refinery, I can say here distillation occurs at atmospheric pressure, and this oil refinery which consists of, rather I can say consisting several towers of refined refinement, and then the product which is obtained, that is known as straight ram product, which is the product after distillation, and this product is taken for further chemical treatments. To be precise, two different chemical treatments. First one is known as polymerization, and second one is cracking. Depending upon the requirement, these two chemical treatments, so further chemical treatments. So, what I can see, rather what we can see from this schematic or the block diagram, that from oil wells we obtain crude petroleum. The crude petroleum, so from oils we get different products, but that is based on the residue after the distillation, and we get crude petroleum which is taken into the oil refinery, which in oil refinery we have several towers of refinements, and there we take crude petroleum at atmospheric pressure for the distillation, and finally the product which we get, that is known as straight ram product, and this product is product after distillation, and this product is taken for further chemical treatments depending upon the requirement, that is we need to go for the heavier hydrocarbon or lighter hydrocarbon. So, either you need to go for the polymerization or we need to go for cracking, essentially to reduce the molecular weight. So, that now this is the basically block diagram from where we get fuel, and this is the subject of chemical engineering. So, and also the details, detailed discussion of this part is not included in this particular course. So, at least we have seen, rather we should know that how we are getting different hydrocarbons which are basically used for the operation of the internal combustion engine operation. So, and finally these are the different process we have seen. Now, question is the final product which we are getting, whether we need for the heavier hydrocarbon, for that we need to go for the polymerization. After the final chemical treatment, I mean after the distillation from the straight ram product, if we need to go for the lighter hydrocarbon, we need to go for the lesser molecular weight, then we need definitely go for the cracking operation. So, these two operation, basically polymerization, this is the operation which to increase the molecular weight, that I can write, or cracking, this process mainly tends to reduce the molecular size arrangements such that molecular weight and size will be reduced. And polymerization objective is to increase the molecular size and weight, just reverse than the cracking phenomenon. So, these two processes are done essentially to obtain the fuel which is required for a particular engine. So, we have seen that the other different kinds of two different processes are done to obtain the particular hydrocarbon which is required for the operation of a particular engine. Now, question is, so depending upon these two different processes from the of the straight ram product, we obtain 5 different I can say hydrocarbon family. So, we obtain 5 different hydrocarbon family, rather families I can write, right. So, again I am telling, from the straight ram product we need to go for, rather we need to go for 2 different processes, rather we need to execute 2 different processes, that is polymerization or cracking. These 2 different processes are required either to increase or decrease the molecular size or molecular weight depending upon the requirement of a particular engine operation. Now, what next we are going to discuss, that is, from these 2 different processes we obtain 5 different hydrocarbon families which are mostly used for the internal combustion engine operations, and the 5 different hydrocarbon families are: number 1, which is paraffin, whose chemical formula is CnH2n plus 2. Number 2 is olefin, whose chemical formula is CnH2n. Number 3 is diolefin, that is CnH2n minus 2. Number 4 is naphthalene, and whose chemical formula is CnH2n, and finally aromatic compounds, that is CnH2n minus 6. So, these 5 different hydrocarbon families are produced depending upon the different processes that we have mentioned, discussed in the last slide. So, although these are basically these hydrocarbons, their chemical formula, chemical structures involve chemistry, but at least we should know that they are different structure, and from their structure we should know different, rather I can say 2 important properties of the fuel, whether they are stable or not stable, and whether they are having unsaturation or the saturation. So, depending upon their molecular structure, these 2 properties are these 2 properties become important for the internal combustion engine operation, and we will see that in the beginning of this course if we can recall that two important numbers we wanted to discuss, that is octane number and cetane number, but these two numbers play in an important role for the engine operation, and that we will be discussing in the context of engine operation. But at this for this time being, we should know the chemical structure as well as chemical, of course structure will depend, and because depending upon the chemical structure we can say whether the fuel will be stable or fuel will be unstable, and based on that we can say okay fine, this fuel is more suitable for this engine operation or vice versa. Now question is, if we know the formula of a particular hydrocarbon family, then in which basis we can say this particular family or hydrocarbon will have less stability, or it is more suitable for say CI engine operation, or another hydrocarbon is important for the SI engine operation, and for that we should at least discuss little bit more about their chemical structure. So, if we take paraffin, that is CN H2N plus 2, and say we are going to consider one example, that is C4 H10. So, if I now draw the chemical structure, so what we can say, C so this is the structure. What we can see that there is no any unsaturation and there is no any double bond. So, again we need to know little bit what we have understood from our 10 plus 2 chemistry, that when the structure is stable or structure is unstable. So, knowing their chemical structure from our undergraduate, from our 10 plus 2 chemistry knowledge, we can say this structure is stable because the structure is not having any no double bond. So, this paraffin is stable, I can say, rather I can say no unsaturation and very much stable. These two are conjugates to each other. That means I can say that if there is an unsaturation, then it is very difficult to say that the compound will be stable. That means the level of unsaturation will dictates the degrees of unstability. So, what we can say, this is the structure, and this is there is no unsaturation and this is very much stable, but at least I should write at 1 or 2 lines about this formula, about this particular fuel, that is if number of carbon atom increases, then molecular weight increases, and consequently boiling point increases. What we can see from this chemical structure of the paraffin, that each carbon atom rather valence of each carbon atom. I can write the valence or valency of each carbon atom is utilized in combining the by a single bond with other carbon atom and hydrogen atom. So, the straight chain, this is the straight chain, this is a straight chain paraffin and this is more stable and largely used for the CI engine, and paraffin and largely used for CI engines, right. So, if we go to next, then we will briefly discuss about the other 4 different families like olefin, that is CN H2N, say C4 H8, and if we try to draw, rather if we try to look at the chemical structure, so there are C4H8, so we can see that this is the chemical structure. We can see what we can see from the chemical structure, that there is one double bond. So, this is one double bond, and since one double bond is there, so this is not saturated. So, this is not a saturated hydrocarbon. So, not saturated. Since this is not a saturated hydrocarbon, it has one double bond and it becomes unstable. So, these 2 important points I am writing, because we will see that whether the fuel is unstable or fuel is not fully stable, depending upon this important characteristic, we can say whether this is suitable for the CI engine and SI engine. Mind that we have discussed the compression ratio, which is the compression ratio for the CI engines are is very high as compared to the compression ratio of the SI engine. Now, compression ratio high, it indicates that the pressure increased because of the compression process is excessively high as compared to that which we obtain for the SI engine operation, and whether the fuel is now at the end of the compression we are injecting fuel. So, at that point of time, in fact, if we try to recall that we have discussed in the context of dual cycle, part of the conversion takes place before piston reaches at TDC. So, what will happen? Now, we are injecting fuel. So, the moment when you are injecting fuel, if the fuel is very unstable, so because of this I can say pressure rise, fuel, the double bond will try to break, and it will be since it is automatically it is already unstable, so it will try to break, and we will discuss that because of that the movement of the piston and also the engine operation will be very rough. So, that will leads to different problems altogether for the internal combustion engine operation. So, what I would like to mention in this context here, that the fuel is the hydrocarbon is saturated or not, depending upon that we can say not only that, maybe fuel is having one double bond. So, this is not saturated, so it is unstable. Now, depending upon the number of double bonds are there in the hydrocarbon structure, we can say the degree of the unsaturation, and depending upon that degree of unsaturation, fuel, whether the fuel will be very unstable, or it will be unstable, or it will be stable, that will be determined. Now, so this is the olefin. Next one is very important, that so because of the double bond, this is very unstable, and this is next is this is number 2. Next is diolefin, that is CnH2n minus 2. So, say C4H6. So, if I try to draw the chemical structure, we will obtain like this. So, you can see there are 2 double bonds. So, there are 2 double bonds. Now, because of this double bonds, we can say this is again not saturated and unstable, and this will become more unstable if we compare diolefin with the olefin. So, diolefins are more unstable as compared to the olefin, and it is so unstable that the fuel tends to gum deposit during storage. So, if the fuel is unstable, again I am telling we need to inject fuel through the fuel nozzle, and it will in the transport of the fuel, that will pressure driven transport. So, there will be huge pressure drop across the nozzle, and at that pressure fuel will try to dissociate, and that will try to, and that leads to deposition at the fuel nozzle, and it will not only it will hamper the engine operation, but also it will try to it will reduce the nozzle life. So, these are the points we need to keep in mind while you are selecting fuel for a particular operation. Next is naphthene, that is 4, and formula is Cn H2n minus 2, sorry H2n, say C3 sorry C5H10. So, if I try to look at the chemical structure of this particular fuel, so, what we can see from the chemical structure of this particular family or particular group is that there is no double bond, no unsaturation, it is stable. So, characterized by ring structure, right. This group is saturated and stable. And finally, we will discuss about the aromatic compound. Cn H2n minus 6 and say what we have studied in our 10 plus 2 level chemistry, that is benzene C6H6, and if we try to look at the chemical structure of this particular group. So, we can write like this. Now, although it is having ring like structure and although it is having double bonds, now even then these aromatic compounds are stable. In fact, they are much stable, but why? So, we have studied this aspect, again I am telling, in our 10 plus 2 level chemistry, that the peculiar structure of this particular group. So, I am writing that although double bond indicates unsaturation, a peculiar nature of this, or rather I can say of this family, causes, the peculiar nature of these I can say bonds, causes the family to be more stable than unsaturated family. Than other unsaturated family. That means, although the structure is having a few double bonds, but the peculiar nature of these double bonds makes the family to be more stable as compared to the other unsaturated family, and this is largely used for the SI engine operation. And these aromatic compounds largely used for SI engines. That means, we have understood that depending upon the number of, as I said that although the carbon atom and hydrogen atoms are varying from one family to other family, but still depending upon their structure, presence of double bond, we can say whether the hydrocarbon will be unstable or unsaturated, but the I can say exception is the aromatic compounds. A typical example is the benzene ring, where we have seen that although the structure consists 3 double bonds, but the peculiar nature of these double bonds makes the family more stable as compared to the other unsaturated family. Okay. So, we have seen that all these 5 families are having different hydrogen and carbon atoms. So, now at least we should give a few we should discuss a few lines about the number of carbon, rather about the characteristics of this of a particular family depending upon the number of hydrogen and carbon atom present in the family. So, what we can say that depending upon the number of hydrogen, so I can general characteristics. That means, we have discussed about 5 different hydrocarbon families. We have seen that the number of hydrogen and carbon atoms present in the family in the structure changes from one family to other family, but depending upon the number of hydrogen and carbon atoms present in the in a particular structure, we would like to draw a few general characteristics, and that is what I would like to discuss now. So, I am writing although a few, at least 2 3 important general characteristics, and that will help you a lot. So, say as one already I have written that depending upon the I have written that if the number of carbon atom becomes more, the molecular weight will be more, and consequently the boiling point will increase. Similarly, I am writing a few. Number 1, that is for the CI engines, normal paraffin are better fuel and aromatics are least desirable. Number 2, in general as the number of atoms in the molecular structure increases. As I said, the boiling point temperature will increase rather I can say increases thus the fuel with rather I can say fewer atom in the molecular structure fuels tend to be more volatile. Number 3, that is very important to know that as the proportion of hydrogen to carbon atom in the molecular structure increases, rather in the molecule increases, the heating value increase because hydrogen is having higher heating value as compared to the carbon atom. So, I am writing again because hydrogen has a greater heating value than the carbon. If this is the case, then we can say paraffins, I am writing paraffins are, the paraffins are tend to have higher heating value. Than the aromatics. So, I am writing aromatics. So, these are a few general characteristics that is we should know, and we have discussed about the chemical structure of different hydrocarbons, and from there we have discussed about the whether the degrees of unsaturation, and from there we have tried to discuss about the whether I can say stability of this particular structure and whether the fuel will be stable or unstable. So, now there are a few important characteristics of the SI engine fuels, and that we should know, because I said that for the SI engine compression ratio is very less. So, the rise in pressure and temperature at the end of the compression is not very high, and for that we need to have one external agent, that is spark plug. So, that important quality of a particular fuel which will be used for the SI engine operation we should discuss in detail again when we will be discussing about the SI engine combustion, but at least for the time being we should know that the fuels which will be used for the SI engine operation will have a few important I can say characteristics. So, I am writing now the characteristics of SI engines fuels. What are those characteristics? Number one is volatility, that we will discuss. Number 2 is sulfur content. Number 3 is gum deposit. So, these three are the important characteristics we should keep in mind while a particular fuel is studied, particular fuel is considered for the SI engine operation. What are those? So, volatility again we will discuss maybe when we will be discussing about the octane number, but other two important characteristics, that is sulfur content and gum deposit, that we will discuss now. So, what do you mean by sulfur content? So, if I focus on this particular point, that is sulfur has low ignition temperature, then the presence of sulfur can reduce the self ignition temperature and promotes the knock in SI engine. So, the word knock is basically a new word that I have introduced here. We will discuss very soon that this is an undesirable phenomenon which is occurring in the context of SI engine operation. We should be very careful to prevent this undesirable phenomenon, but in this context what I have written that sulfur. So, when you are using any hydrocarbon, I mean gasoline. So, gasoline contains some sulfur. So, which has, when the gasoline is coming in contact with oxygen, so sulfur will try to react and it will try to because of the chemical reaction it will try to produce other products. So, what I would like to say that almost all the gasoline contains some sulfur. So, the sulfur has the low ignition temperature. Now, what we will do, the presence of sulfur will try to reduce the self ignition temperature of the gasoline and it will try to promote the knock, and that is what we should know for the time being, that by reducing the self ignition temperature what will happen, that it will try to reduce the tendency of pre ignition, I can say localized I can say burning. So, this will try to accelerates the knocking phenomenon in the context of SI engine operation. So, we should be careful about that. Finally, this is another important, that is gun deposit. What do we mean by that? I can write that certain unsaturated hydrocarbons have an inclination to oxidize during storage. And form a product known as gum, and form a product which is known as gum. Now, so this is one important point, this is another important point. Now, this gum tends to cause undesirable deposits on intake valves, piston ring, and as well as clogging of nozzle or carburetor, if it is carburation system, or nozzle if it is fuel injection system. So, I am writing these two, that gun deposit. So, certain hydrocarbons have the tendency to oxidize during storage, that is what I was discussing about, that if it is unsaturated it will become unstable. So, they will try to be dissociated even during the, rather they will be oxidized even during their storage. So, during their storage this I can say oxidation will leads to formation of gum deposit. Now, rather deposit which is known as gum, they will try to deposit on the intake valves, other parts of the engine, piston ring. More importantly, they will try to clog the carburetor, and if it is carburation system, and if it is fuel injection system, they will try to clog the nozzle, and that is what we have discussed. In fact, in one of my previous classes where we have seen the pintle nozzle. So, because of this clogging by the gum deposit, we need to have pintle, that is kind of that movement of the pintle will try to clear the deposition that will be there. So, these three are the important characteristics of the SI engine fuel, that is volatility, depending upon it should have, I mean whether it will have low boiling point or high boiling point, that is very important, that we will discuss. Sulfur content, if it contains sulfur, what will be the problem, that is what I have discussed today. And because of this there are a few hydrocarbons which these hydrocarbons have tendency to oxidize during their storage, and as a result of which there will be deposition, and that deposition will lead to kind of clogging of the nozzle and other parts, and that is detrimental for the engine operation. So, now we will briefly discuss about so these are the different fuels, their chemical structures. From their chemical structures we have tried to understand the their suitability for a particular engine operation, and finally we have discussed about the characteristics of the SI engine fuel. So, now we briefly discuss about there are a few fuels which are not conventional, but those are used nowadays because of the scarcity of the natural fuel. So, alternative fuels, and we will be discussing about 3 different alternative fuels. Number 1 is methyl alcohol, that is methanol. Number 2 is ethyl alcohol, ethanol. Number 3 is hydrogen. Now, again I am telling because of the scarcity of the natural fuel, these fuels are used nowadays. Rather, research is continuously going on to see their suitability as a fuel for the internal combustion engine operation, and these 3 different types that we have mentioned here. Among these 3 different types, methyl alcohol, methanol, it has methanol has got huge impact, I can say potentiality for the application as a fuel for the internal combustion engine operation. Rather I can say methyl alcohol is one of the promising alternative fuels which is used largely even nowadays for the internal combustion engine operation. What I can say that when we talk about alternative fuels, it is very difficult to say that only these fuels can operate the SI engine, rather they themselves alone cannot run the engine. We need to mix, we need to blend this fuel with the other gasoline, rather conventional gasoline. Methyl alcohol itself can be used rather for the engine operation, but what I would like to say that even then methyl alcohol is mixed with certain gasoline, of course to maximize the engine efficiency and engine performance. But while we are talking about blending, that is mixing with other gasoline, then mixing of methyl alcohol with other gasoline creates a problem, and that problem I should discuss now. What is the problem? Say we are mixing methyl alcohol with the gasoline, so I am writing that gasoline alcohol mixture as a fuel. That is what I would like to say, that methyl as a fuel has a tendency for alcohol to combine with any water present. So, when this happens, then methyl alcohol separates from the gasoline and results in a, I can say, non-homogeneous mixture. So, this is the problem. What will be the ultimate problem? Engine operation will be erratic. So, this is the problem with the methanol, that gasoline alcohol mixture as a fuel has a tendency for alcohol to combine with any water present. If that is the case, rather if that happens, then methyl alcohol will try to, rather will separates from the gasoline and results in a non-homogeneous mixture, and if this happens, then ultimately engine operation will be very erratic. And that is why I can say that, but so this is the problem. So, when we talk about alternative fuels, we need to consider a few points. First of all, it can be used. Methyl alcohol by itself is not a good CI engine fuel, but I mean it is used for the dual CI engines. We can blend this fuel with the other gasolines for the engine for the to maximize the efficiency, but when we try to mix alcohol with gasoline, we will have a problem. That is what we have mentioned here. Second thing, if we talk about the emission, then of course methyl alcohol, if I use methyl alcohol as a fuel, then emission, I mean of course not a pure methanol, but methyl alcohol with some gasoline, then the emission will be same what we have seen, rather as those using gasoline itself as a fuel. So, what I understood that, and methyl alcohol if I use as a fuel, then emission of methyl alcohol with, I can say 90% gasoline is same as those using gasoline. So, this is the case. So, emission, if we need to consider a few points, we cannot use methyl alcohol. I mean methyl alcohol itself is not a good fuel for the CI engine. It can be used for the dual CI engine, but with proper blending we can use methyl alcohol as a fuel, and mixing methyl alcohol with gasoline will create, rather is creates a problem. That is what we have discussed. And finally, the emission is very important to know, but emission of methyl alcohol with 90% gasoline is same as though using gasoline. Next is ethyl alcohol. So, ethyl alcohol is also used, or ethanol is also used as a fuel, but ethyl alcohol is, I can writing that ethanol is obtained from ethylene or from the fermentation of food items, grains or sugar. So, this is what is very important to know. Now, although ethyl alcohol we can used, I mean it is largely used in other countries, but the production cost of ethanol is very high. So, I can write that production cost of ethanol is very high due to associated manufacturing cost. So, that is why it is not, I can say recommendable, but the production cost can be reduced if large amount of fuel is used. But again, if we would like to use ethanol extensively as a fuel for the internal combustion engine operation, then we will have food fuel problem, because ethanol is largely obtained from the fermentation of the grains and sugar. So, what will happen? We have understood that when we talk about ethanol as an alternative fuel, it is obtained from the ethylene or from the fermentation of the grains and sugar. Production cost is very high, but again I am telling, ethanol itself cannot be used as the fuel for the engine operation. We need to mix this again with the gasoline. Now, but the production cost is so high that it is not recommendable, but the production cost can be reduced if ethanol is used extensively as a fuel for the internal combustion engine operation. But for that case, again we will have kind of food fuel problem. So, this is another important. And finally, we need to know about the emission characteristics. So, ethanol as a fuel has less emission than the gasoline, but more than methanol. So, this is the emission characteristics. Finally, we will discuss about the hydrogen as a fuel, its potential applications, and finally, we should know that hydrogen has potential to replace gasoline as the fuel for the internal combustion engine operation, but there are a few advantageous features that we need to know. On the other hand, although we have a few advantageous features of hydrogen if you would like to use it as a fuel, but at the same time we need to know what are the different disadvantageous features. Keeping those disadvantageous feature in mind, we should be careful about using hydrogen, and if we need to use hydrogen as a fuel, then what are the precautions, what are the remedies we need to take into account, so that the disadvantages, problems associated with the this kind of fuel can be reduced. So, now if I try to write the hydrogen, if I use as a fuel, then what are the advantages, right? High octane number. While I am writing high octane number, the physical significance of having high octane number can be understood when we will be discussing the definition of the octane number in details. So, for the time being we should know at least the hydrogen, if I use as a fuel, it is having high octane number. So, high octane number, and also can be used for high equivalence ratio, can be used at a high equivalence ratio and compression ratio I can write, and this I can say makes for high thermal efficiency. Number one, Number 2, low emission, that is most important. Essentially no carbon monoxide, carbon dioxide and HC in the exhaust, that is again I am telling most important. Number 3, fuel availability. So, there are number of different ways of obtaining hydrogen. Including electrolysis of water. So, these are the a few advantageous feature. So, the first one, that is high octane number, I will be discussing this aspect in a greater detail when we will be in a position to define octane number and other important points, but can be used at a high fuel equivalence ratio and the compression ratio. So, it will make another efficiency will be, it will make efficiency to be higher. Now, most importantly low emission, that it contains no CO, CO2 and HC present in the exhaust, and fuel availability, that there are a number of different processes which can be used to obtain hydrogen, which includes electrolysis of the water. But at the same time we need to know a few disadvantages. So, what are the disadvantages of hydrogen as a fuel? So, what are the disadvantages we have? So, this we need to know, very important. So, we should list down the different disadvantages. Number 1 is storage, that is what I have discussed about the gaseous fuel. Storage will be a severe problem, for the storage, as I mean carrying the fuel as well as storing in the inside in the engine. Second thing, I can say poor engine volumetric efficiency, because any time a gaseous fuel will try to replace the air from the inlet, and rather I can say any time a gaseous fuel will try to replace the air from the inlet, and it will leads to reduction in the volumetric efficiency. Number 3, high fuel cost, storage, that is bulk storage tank, and both in the vehicle and as well as at service station. And high fuel cost. Number 4 is fuel can detonate. So, these are the a few disadvantageous features of hydrogen as a fuel, and we need to have find out different ways. Storage cannot be reduced, the problem associated with the storage will be always there, but we can increase the volumetric efficiency, and we need to think how we can reduce the fuel cost, that is the cost associated with the generation of hydrogen, and then by mixing some additive we can also prevent the detonation. I can increase the detonation quality. So, to summarize today's discussion, we have discussed about the conventional fuel, how we can obtain a particular hydrocarbon, then we have seen their chemical structure. Knowing the chemical structure, we have identified that whether the fuel will be stable or unstable. Then we have identified a few general characteristics along with the characteristics of the SI engine fuel, and then finally we have discussed about the important points, important aspects of 3 different fuels which are used as an alternative fuel for the SI internal combustion engine operation. So, with this I stop my discussion today, and we will continue my discussion in the next class. Thank you.